In this video, we're going to take a look at area and volume and their measurements. I think I want to start this with a very basic idea, and that's area. So what I have here is a rectangle. Let's say it measures 15 feet by 10 feet. The area is calculated, depending on how you've seen it in your life, base times height or length times width. It really doesn't matter. You're going to do 15 feet times 10 feet. And when you multiply it together, you get 150, but we keep the feet. In fact, feet times feet is feet to the second power. So that's how we know this to be area. So we want to keep track of the units as we go. Dropping the units altogether is a bad idea, as we're going to need them as we do conversions. Here's another one, same deal. Area, I'll use the letter A for area, is base times height. That's 4 centimeters times 7 centimeters. And that equals 28 centimeters squared. This table comes out of the textbook. You can see we've got the various square measurements. One of the ones that probably you should be most familiar with, at least in words that you hear normally in your everyday life, are these things. Square yards, typically you'll buy carpeting in that unit. Acres is quite a popular unit of measure for land. And then we have square inches and square feet for smaller things. So let's go and do an example to show how this works. You have to have these tables in front of you. You're not expected to remember what any of this stuff is. You don't have to memorize any of these things. You'll be allowed to use these tables. So I want to show you how to use the tables, and it works just like we did in the last video. Convert 150 square feet to square yards. So as usual, we'll start with 150 feet squared, and I'm going to multiply it by a fraction. And what I want is I would like feet squared to be in the denominator and yards squared to be in the numerator if I can have it. That means I want to look at my table and see if there is actually one that I can employ that directly connects square yards to square feet. And as I look, the one that I have this arrow to here is exactly the one I want. 1 square yard, it says, is equal to 9 square feet. And so I can cancel my feet squared, and I'll end up with 150 over 9 YD squared. Let's pop this out on the calculator. I get 150 divided by 9. We end up with 16 point, well, to 2 decimal places be 0.67, but whenever I get a chance to, I like to use the bar notation, so I'll put 16.6 with a bar over it, square yards. Let me illustrate something. I don't know that I did it in the last video, and I think it's important. 1 square yard equals 9 square feet. So if I divide both sides by 9 square feet, I get the following. On the one side, I get my 1 square yard divided by 9 square feet, and that equals the number 1. So in the textbook, if you're following along, they'll often say multiply by a unit fraction, or I've heard people in the past say multiply by unity. Whatever you want to call it. Let me reiterate very carefully what we did in the last problem. We started with 150 feet squared. Now you happen to know that if you take any quantity at all and you multiply by the number 1, you have not changed it at all. You can multiply by 1, it stays the same value. But then instead of that 1, I'm going to put in its place the fraction, this guy right here. In fact, it equals 1. So I have 1 square yard divided by 9 feet squared, and you can see how we got the cancellation as we needed. So all of these problems, all of this dimensional analysis is just simply multiplying by the number 1, but in a tricky way. Convert 1,000 acre to square miles. Now notice we don't have acre squared because acre is some sort of a measurement that already involves two-dimensionality. So what we just need to do is hopefully go right to the table and see if there's a connection between acres and square miles. So we'll start with 1,000 acres. And then if I'm lucky, I'll be able to get an ACRE in the denominator and an MI squared in the numerator. Let's take a look if that table has anything like that for me. Is there a direct connection between square mile and acres? And yes, I have an arrow to it right there. 1 square mile is 640 acres. So 1 square mile is 640 acres. So that fraction that I just finished right there is equal to 1. Get rid of acre, and we end up with 1,000 divided by 640 square miles. Let's go ahead and get the calculator on this. I think I'll keep all the decimals here since there's only 4 of them. 1.5625. As you can imagine, the metric system has its version of tables. The metric system is a much easier to memorize collection of equations because everything is based off of a single unit. In fact, everything seems to be based here on 1 square meter, probably in the same ways that our system would be based on 1 square foot. Anyways, let's do some examples. Once again, you don't have to memorize this. Just keep the tables handy when you're doing the problems. Let's convert 20 square meters to centimeters. And so as usual, we'll start with 20 meters squared, and if we luck out, I'll be able to get a meter squared in the denominator, but a cm squared in the numerator. So let's take a look if I have that. Well, actually where my arrow is exactly the thing that I'm looking for. 1 square meter is equal to 10,000 square centimeters. So I can wipe out these square meters. And it looks like what I'll end up with is 200,000 square centimeters. Convert 2,400,000 meters squared to kilometers squared. Since it involves meters squared, I have a feeling there may be a direct connection there. Let's try it. So I'll start with my 2,400,000 meters squared and hope for the best. Km squared on top, m squared on the bottom. Let's take a look at that table. It looks like we do have what we're looking for here this time. 1 square kilometer is equal to 1 million square meters. So I can wipe out my square meters. And this division, I'm actually able to do it in my head. If I have 2.4 million divided by 1 million, that's 2.4. Now we have the table that connects English and metric together. One thing that I find ironic about the English system of measurements is while they did come from England, England has abandoned those years ago. Only Americans seem to want to stick to the system. As usual, notice the squiggle lines means not exact. We happen to know that 1 inch equals exactly 2.54 centimeters. So if I square both sides, on the left I'll get 1 square inch, but on the right I'll do 2.54 times itself, or squared, let's do that. So the exact answer would be 6.4516. Oh, a hectare? I think I should probably tell you. I don't even know if I'm saying that right, but I'm going to go with hectare. You ought to know that 1 HA equals 10,000 square meters. But this table right here is a connection between the English and metric systems. So we're going to do some examples, obviously, to convert the two of them. Let me show you something. This is a basic conversion for large land masses. What we have is the following. I did a little research here and I looked up the definition of an acre. And this was a strip of land that was 66 feet thick, I guess, by 660 feet long. This is an acre. Notice that an acre is smaller than a hectare because a hectare is defined to be this quantity. A hectare is defined as a square that is 100 meters by 100 meters. So you get an idea how the two can compare to each other. If you're having a hard time seeing it, remember that each of those meters is bigger than a yard. So that square that is 100 meters by 100 meters is bigger than a square that is 300 feet by 300 feet. So the way I drew it is obviously not a good comparison because it makes the acre look so much tinier than 0.4 of a hectare. It's just hard to imagine. Anyways, the area of an acre, if you multiply 660 feet by 66 feet, you end up with 2,874,960 square feet. So my first example is convert .535 hectare to acre. This probably would be a connection that would be good if I were, say, I were an investment person, investing in real estate in other lands, say in England perhaps, or any other country that uses the metric system. I would think of purchasing in American in acres, but in their system it'd be hectares. So I would purchase hectares, but when it comes back to figure out how much land I own, I might have to go through acres to figure that out. Now, as usual, nothing is different in this problem than anything else. You start the same way as all of them, and we hope, if I look out, I can get a direct connection between hectare and acre. And I know there is because we just looked at the table. It's in that last line right there. 1 acre is equal to 0.405 hectare. So I can get rid of that. And the rest of the problem, of course, then, is a calculator exercise. 535 divided by 0.405. And we end up, if I'll round to 3 places, 1,320.988 acre. Convert 12.9 square feet to square centimeters. If I luck out, there's a direct connection in that table. It doesn't look like I have a direct connection between square feet and square centimeters. I've got square feet to square meters, so I've got this one. But then I could do, can I do square, well then I could do square meters to square centimeters. So that wouldn't be too bad. Or if I wanted to, I could, instead of that one, use this here because I do know that 1 square foot is equal to 144 square inches. So I might use that one. That seems a little bit easier from my mind. So unfortunately, I don't get to use these directly, but I can do 1 square feet is 144 square inches. Now what that does is it puts me in square inches right now, but I can now get myself out of that because I know there is a connection between square inches directly and square centimeters. Let's see what that is. We have 1 square inch is approximately 6.45 square centimeters. So I get my inches squared out, and I'm left with centimeters squared, and you can see I have nothing in the denominators. It's all numerator action. Let's go ahead and multiply it out. 12.9 times 144 times 6.45, and we end up with 11,981.52. And don't forget your centimeters squared. I want you to note something. If you use tables that are different from ours, and your answers are different from our answers, it's because we're rounding in our tables, and almost without any question in my mind, whatever tables you're looking at almost certainly have roundings as well. So everybody's rounding and nobody's getting the exact answer. The exact answer in this case, by the way, happens to be this number, 11,984.49216 centimeters squared. So you can see it's off by 3 centimeters, but one thing that they typically do when they're looking at how far an answer is off, we look in terms of how far it's off relative to the size of the number itself. If you look at 3 from close to 12,000, 3 is a small, fairly insignificant quantity. Now, one thing I need you to understand this is that area is a 2-dimensional measurement. And the rectangle is a perfect example of that. You're doing base times height. And if you think of left to right as one dimension and up and down as another dimension, that gives you the 2 dimensions. Volume, on the other hand, is a 3-dimensional quantity, and that's what we're going to look at next. Now, the basic definition of it doesn't seem to have the quantities that we think of in terms of a volume of something, but I'll show you how they're connected. So let me draw what amounts to a 3-dimensional box, a cube if you want, but it's not going to be perfectly square. So here's my box. We'll call this L, W, and H. The volume is V equals L times W times H. So if a very simple example might be this. Let's call this one 3 inches, this here 2 inches, and then let's call its height 1.1 inches. So for its volume then, I'll take 2 inches times 3 inches times 1.1 inches, and I'll get a total of 6.6 cubic inches. All right, here are our systems of measurements in the English system. Oh, by the way, when you go and look up the English system and say you're having a hard time finding it, many times you'll find it listed instead under the imperial system, because as England was trying to conquer the world, the system of units became known as imperial units because England was using them at the time. Anyway, what I find most interesting about these is we have the exact numbers. You can see the equal signs. They're not squiggles, except below here when we talk about capacity, which is the same as volume, the quantity that you hold. So you can see that a cubic yard is related to gallons and a cubic foot is related to gallons, and everybody knows gallon is sort of our unit of volume measurement. What I find interesting is the last one, that equal sign. It is exactly equal. 231 cubic inches is equal to 1 gallon exactly. A funny story should happen as a result of that. I was looking this up, trying to figure out how that is actually exactly equal, and I found out. What they tried to do to define a gallon is they took a cylinder, and the radius of this is 3.5 inches, and the height of it is 6 inches. So the volume for something like this is pi r squared h, where r is the radius and h is the height. This is exactly equal. So let me continue. I'll keep pi there, but our r was 3.5, so I'm going to have 3.5. I'm going to square that quantity, and then I'm going to square the 6. What you end up with is 73.5 pi. However, that will end up having a decimal that will never end. Take a look at the calculator's version of it, in fact. If I do 73.5 and I multiply it by pi, that's the wrong constant. Let me go up here, and I think there's my pi. You can see it's slightly under 231 cubic inches. But not to be deterred, many times when they come up with a standard, they don't like to have an infinite number of decimals as part of the standard. So here is what was authorized by Queen Anne. The volume was able to be done this way. The 73.5 was fine, but pi wasn't. Pi is the thing that has an infinite decimal. So what they did is they used an approximation for it. 22 divided by 7. This was a well-known approximation. It had been known since Archimedes' time. Anyways, look what happens when I do the multiplication now. We're going to take our 73.5, but now I'm just going to multiply by 22 and divide by 7. And we get our 231 exact. So by Queen Anne decree, this last equation is exact. The funny thing about it is England hasn't used that system since the early 1800s. We in America have decided to stick with this. We're not the only country that uses gallons. When oil is purchased, oil is usually described in terms of some sort of gallons. And I think 42 gallons made a barrel of oil at one time. But don't quote me on any of those numbers. Anyways, let's go ahead and do an example. An in-ground pool has the following dimensions. Let's say it's 25 feet long, 10 feet wide, and 6 feet deep. How many gallons do you need to fill the pool? So first, let's get our volume. Our volume, we simply multiply the three dimensions. So I'll take 10 feet times 25 feet times 6 feet. And I end up with 1,500 cubic feet. Now what I would like to do is change that to gallons if there's a direct connection to gallons. So I'll start with my 1,500 cubic feet, and I'll see if there's a connection between cubic feet and gallons. Right, there it is. 1 cubic foot is approximately 7.48 gallons. Take out my cubic feet, and all I got to do is 1,500 times 7.48. And I get 11,220. Gallons. Of course, this would be important to you. If you are the pool owner, you would do the measurements, and then you would call, or you would go to the store with your measurements. Somebody would have to do a gallon conversion because you don't buy water in cubic feet, you buy it in gallons. Now, if you had gone another direction, instead tried to go through cubic inches to get your answer will be different from this simply because of the rounding. Now, when you fill a pool with water, typically I've seen water trucks actually come up and fill the pool. I don't think you stick your hose into it and then try to fill it up that way. I think it'll take several summers to fill it up if that's the case. So people typically do buy it, and they usually buy it as a per gallon cost. So let's say pool water costs about 3 cents per gallon to deliver. So they're going to bring it in, pour it in your pool for 3 cents per gallon. How much will it cost to fill the pool? Well, you know how this works. We take our gallons, we have 11,220 gallons, and we multiply by 3 cents per gallon. Remember, per means to divide. So these gallons actually do cancel out just like the rest of the problems, and we simply do our multiplication. So 11,220 times 0.03, and I get 336.6. This ends up being $336.60. Another area where there's a connection that we use all the time is in cooking. In there, volumes are used all over the place. In fact, we're quite familiar with these measurements. 1 cup equals what we define to be 8 fluid ounces. FLUIDOUNCES. Whoever came up with OZ for that, I don't know. But anyways, we use fluid ounces when we're talking about liquid volume. We use a slightly different term when we're talking about dry volume, but we're not really going to worry about that. We're more concerned with these connections right now. So I have then 1 gallon equals 128 fluid ounces. We have 1 quart equals 32 fluid ounces. And they keep going down. We did I haven't done this one yet. 1 pint is 16 fluid ounces. And then we did 1 cup, which is half of a pint. You can see that according to the table. So everything in terms of fluid ounces is given, everything in cooking is given in terms of fluid ounces ultimately, or in cubic meters or cubic centimeters when you go to metric. Let's go ahead and do an example with this. A recipe for 4 calls for 1/3 cup of sugar. Sergeant Travis figures she needs to serve 5,000 soldiers. Sugar is sold to the army for 25 cents per pound, and each pound is 2 1/4 cups. So you see here, there's no, I'm not saying that 1 pound of anything equals 2 1/4 cups of anything. I'm saying the weight of sugar comes out to be equivalent to 2 1/4 cups. Now, 1 pound of molasses may have a different number of cups because it weighs differently. So anyway, Sergeant Travis is probably going to have to put in for this order, so she needs to know how much is the sugar going to cost. Well, notice the recipe calls for 4. So what we first need to do is we're going to have 5,000 divided by 4 that's going to equal 1,250 servings. And each of those servings called for 1/3 cup of sugar. So I can take my 1,250 servings and multiply it by 1/3 cup per serving. And instead of that, let me erase it. It didn't look good anyways. You can always think of it as divided by serving. So 1/3 cup per one serving. I can wipe these servings out. And this is what we have so far. 1,250 divided by 3 cups. Now she is charged by the pound, 25 cents per pound. So I've got to get to pounds somehow. So let me have my 1,250 divided by 3 cup. And let's see if I can get out of this thing. I know that 1 pound, so we use LB for pound. Don't ask. 2 1/4 cup. So I can wipe the cups out. Now this is a little bit complicated. I'm going to go ahead and get my number here because I really need to know the amount of pounds that I have. So let's have this calculator and let's see how much of it I can do right off the bat. So I'm going to have the 1,250. That was all part of the numerator. But in the denominator, I had 2 items. I had the 3. Then I got times 2 1/4. You can do 2 1/4 probably. I would prefer to do it this way. I'm going to do 2.25. That's my version of 2 1/4. And let me hit enter and see what we end up with. So I have 185 pounds. So let me go to 3 decimal places. It looks to me, let me stop. It looks to me like the 185 actually repeats. Well, that's interesting. So we have 185.185 bar pounds. So now I just got to figure out how much that's going to cost. So now I need to go to the dollars. And we simply multiply. I take my 185.185 with a bar over it, pound, and I multiply it by 25 cents per pound. And that's per 1 pound if you need to know that. And let's go ahead and do this multiplication. So since I'm going to use the bar of it, I'm not going to round at all. I'm going to just multiply the previous result by 0.25. And we end up with approximately $46.30. In our textbook, we have the volumes listed in metric, and this is our base here. Just like gallon is a base in our system, liter is the base in their system. And what we need to know is some sort of a connector between metric and English, and that's what comes next. Now I want you to see this. We have the connector is this. 1.0567 quarts is exactly equal to a liter. Once again, that might have been by some king or queen's decree or whatever the case may be. There's interesting history behind all of these things. So this is a definition. This is to be taken as exact. So we're going to write that just so you keep that in mind. And then it's a good thing to use when you're, say if you make your way up to Canada, the first thing you'll notice is how cheap gas appears to look. But then as you look, their gas is listed as costing per liter, and a liter is much smaller than a gallon. A 12-pack of Coca-Cola costs $6.29. What is that cost per liter? First, we're going to have to know how much volume we have in a 12-pack of Coca-Cola. Each 12-pack contains 12 cans, obviously, but each can is 12 ounces. So we have 12 cans times 12 ounces. And when we say ounces, we misuse them when we say them, and I should be careful. That's fluid ounces. So what you're going to end up with is a total of 144 fluid ounces. I should probably do this. That's 12 fluid ounce per can. And then I could even cancel out the cans. And so there's our volume, 144 fluid ounces. And according to what I just wrote, our price works this way. We have $6.29 per 144 fluid ounces. What I ultimately want to end up with when I'm all said and done would be dollars per 1 L, 1 liter. That's where I want to get to. I think the easiest way to go here is something like this. We can probably get fluid ounces per quart. Let me check that out, because then I got the quart to liter connection. So let me come back here and see if I've got a fluid ounce to quart. Oh, there it is right here. I don't think I made enough of a statement here. So 1 quart is 32 fluid ounces. Let's get it in there then. So I know I have a 32 fluid ounces divided by 1 QT. So I can wipe out my fluid ounces. And now I have $6. I got all this stuff per quart. Now then I have to get liters in the bottom. So I'll put my L down here and my QT up here, and we have right on the screen the connector, 1.0567 QT per liter. And then I can cancel out the QTs. And so in the end, I have exactly what I'm looking for. Now let's grab the calculator and see what we get. So in my numerators, we have 6.29 times, let me actually make it a 9, times 32 times 1.0567. That's all the end of the numerator. Then I can divide by 144. Enter. It looks like about $1.48 per liter. Now you might notice that a regular 2-liter pop, if you buy a bottle of 2 liter, it's about $1.99, about $2. It's cheaper to buy it by that quantity than it is packaged in cans. Usually the smaller the quantities that they package things in, the higher the unit cost of those items. Here is a problem that I'm giving that is out of the textbook. And this is a typical style of problem that nursing students will see and they have to deal with. This is an IV order for a patient, and they're going to administer a total of 1,300 milliliters of saline, but they're going to do it at 80 milliliters per hour. So if you begin at 4 a.m., at what time will it be finished? So what you're doing is this, it's sort of weird, but you're going to take this much time. You're going to take 130 or 1,300 milliliters, and you're going to divide by 80 milliliters per hour. I'll use HR for that. This may be strange what happens, but if you'll remember, when you take a fraction and divide it by a fraction, this is no different than doing 1,300 milliliters divided by 1, all of that divided by 80 milliliters per 1 hour. You may remember to multiply fraction, or when you divide fractions, that is, that you take the reciprocal of the bottom fraction and you'll get 1 HR divided by 80 ml. That wipes out the mLs and it will tell us how much time it takes. So all I have to do is this 1,300 divided by 80 hours 16.25 hours. It'll be finished at 10.25 o'clock. That's typically not the way that people say it. So instead of this, let me write 16 hours and 15 minutes. Because a quarter of an hour is 15 minutes. So this is better. We started at 4 a.m., then we're going to finish at 10:15 p.m., or if you like the military time, 20:15.